Welcome to another lesson. In this lesson, I'll be introducing batch scripting for security and explaining why batch scripting is absolutely essential for every cybersecurity professional. So let's dive in. Why do we need batch scripting? Let's talk about the problem first. As a cybersecurity professionals, we face some major challenges. Manual repetitive tasks are extremely time consuming. Imagine checking logs on 50 servers manually, one by one. That could take hours. We also find ourselves typing the same commands repeatedly. If you're running the same sequence of commands 5 times a day, that's a lot of wasted time and effort. Human error in complex procedures is another huge issue. When you are typing 20 commands in a specific order, it is easy to miss a step or make a typo. One mistake can compromise your entire security assessment. And finally, inconsistent security checks. When different analysts run checks manually, they might do things slightly differently, which could lead to gaps in coverage. These problems slow us down and introduce risk. That is where batch scripting comes in. The solution is automation with batch scripts. When you write a script once, you can run it anywhere, anytime, because you've captured your knowledge in a reusable tool. Also, this saves massive amounts of time and effort. A script that took you 30 minutes to write might save you 2 hours every single day. It also ensures consistency. The script runs exactly the same way every time, following the exact same steps in the exact same order. No human error at all. And it reduces mistakes. Once you've tested and debugged your script, it works reliably. You are not going to forget a step or make a typo at 2 a.m. during an incident response. So, batch scripting turns you from a manual operator into an automation engineer. Let me now give you 5 real-world use cases where batch scripts are absolutely critical. The first one is system reconnaissance, which means instead of manually running host name, who am I, uname, IP address, and 20 other commands, one script can gather all operating system information, network configuration, and user details automatically. It also generates a comprehensive report with everything timestamped. And this is what professional penetration testers do on every engagement. The second one is log analysis. Your script can scan authentication logs for failed login attempts, detect brute force attacks by counting failures per IP address, and alert you immediately when suspicious patterns appear. This turns hours of manual log review into seconds of automated analysis. The third one is user auditing. A batch script can find all users with UID 0, which means they have root privileges. It can identify weak password policies and check for unauthorized accounts. And check for unauthorized accounts that shouldn't exist. This is essential for compliance audits. The fourth one is file integrity monitoring. This means that scripts can detect when critical system files have been modified, compare current file hashes against a known good baseline, and alert you immediately on unauthorized changes. This is how you catch attackers who try to modify system binaries. And the fifth one is automated backups. This means that scripts can back up important data before you run security tests. It can help schedule regular backups of critical files and maintain evidence integrity during investigations. You never want to lose data because you forgot to back it up first. Let me show you when security professionals actually use batch in their daily work. For incident response, batch scripts enable quick data collection from compromised systems, evidence preservations that's forensically sound, and timeline generation showing exactly what happened when. In penetration testing, scripts automate reconnaissance across entire networks, create custom exploit helpers for specific vulnerabilities, and generate professional reports automatically from your findings. For system hardening, scripts perform security configuration checks across hundreds of servers, validate compliance with security standards, and even handle automated patching to keep systems secure. And for threat hunting, scripts search for indicators of compromise across your entire environment, correlate logs from multiple sources to find patterns, and detect anomalies that humans would miss in massive datasets. These real-world use cases we've considered means that bash is everywhere in cybersecurity. Now let's look at the structure of a bash script. Every bash script has 5 components, and this is a snippet of what the bash script structure looks like. Now, to explain that better, I would like to mention the 5 components. And the first one is the shebang. And this tells the system to use bash as the interpreter. It must be the very first line. The second one are the comments, and this starts with hash symbol. They really help us with good documentation because it is essential. The third one are the variables. Variables store data. This means that we can capture the host name, current date, or user inputs in variables to use later. The fourth one are commands, and these are the ones that do the actual work. They are the Linux commands such as echo, grep, awk, find, and whatever command you need. The fifth one are the exit codes, and these are the ones that signal success or failure. Exit 0 means success, exit 1 or higher means something went wrong, and this is the structure that keeps our script organized and professional. An important question is, when should you automate versus when should you run commands manually? Use manual commands for one-time tasks that you would never repeat. You can use it for quick checks when you just need to verify something first. You can use it for exploring unfamiliar systems when you are learning as you go. And you can use it when you are doing an interactive troubleshooting where each steps depend on what you found in the previous step. But if you want to use batch scripts, use batch script for repetitive tasks that you do regularly. Use it for multi-step procedures that require many commands in sequence. Use it for scheduled automated checks that run daily or hourly. Also for standardized audits that must be done exactly the same way every time, and for anything you find yourself doing more than 3 times. The golden rule is the rule of 3. If you type the same sequence of commands more than 3 times, write a script. Don't waste time doing same thing manually over and over. You might be wondering, why Bash instead of Python or PowerShell? And here is when to use Bash. Bash is perfect for Linux and Unix system administration. It is pre-installed on every Linux system, so there's no setup required. It is fast for quick automation tasks, and it integrates natively with all system commands. Now, when do we use Python? Python is better for complex data processing that Bash struggles with. It is good for web scraping and API interaction. It is also good for cross-platform tools that need to run on Windows, Mac, and Linux. And lastly, it is very good for advanced algorithms that require proper data structures. How about PowerShell? PowerShell is for Windows automation. If you're managing Windows Server and Active Directory, PowerShell is your friend, but it is not standard on Linux. And you may be wondering, what is the best practice? Yeah, I will tell you to combine both. Use Bash for system orchestration and calling commands, and use Python for complex data processing and analysis. Together, they are incredibly powerful. Let me summarize the key takeaways from this lesson. Bash scripting automates repetitive security tasks, saving you hours of manual work. Real-world uses include reconnaissance, log analysis, auditing, and monitoring. These are things you will do every single day as a security professional. Scripts have 5 components: shebang, comments, variables, commands, and exit codes. This structure keeps everything organized. Automate tasks you do more than 3 times. The rule of 3 saves you from unnecessary repetition. Bash is perfect for Linux system automation because it is pre-installed, fast, and native to the operating system. And in our upcoming lessons, we are going to build practical security tools that you can actually use in real work. Let's take a test together. Here is the question. What happens if you forget the shebang line at the beginning of your bash script? Here are the options. Pause your video and read through the options. Pick your answer and drop in the comments, then come back to play the video. What's the correct answer? The correct answer is B, which is the script will run using your default shell, which might interpret commands differently than bash. That's all for this lesson. If you'd like to subscribe to our YouTube channel, please do that now. Also, do not forget to like, share, and comment. Thank you so much, and see you in the next lesson.